Hi guys, good evening. In the previous session, we have seen, they are not here, buddy. I think intro prep is not necessary for them from now onwards. No one will join. Okay. All right. Yeah, I'll convey your congrats. All right. Okay. So guys, in the previous session, we have seen all about the TCP. So there are 3 sessions done for a TCP, if I'm not wrong, right? 3 sessions, not only 3, there are 4 sessions actually. Let me show you. There is interview prep, September. So overall, TCP part 1, part 2, part 3, and here we had a discussion about the interview. Over there also I have explained some things about the TCP. So basically you can consider like there are 3 parts based on TCP. First day is OSI, then subnetting, then we did ARP. So today we'll be going with the concept of NAT. Okay. See guys, now tell me how many types of NAT are there? Don't security students don't answer. Let the CCIE and NP students answer this question. How many types of NAT are there? N and NP students, come on.
Static NAT, dynamic NAT.
Okay, 2 types. What is that, Aves? Aves?
Source NAT, destination NAT.
Yes,
Aves?
sir.
Yeah.
Yes, sir. Yes,
Which
yes, sir. Source net, destination net, and dynamic and static.
Okay, so overall, as per your understanding, there are 4 types of NAT then.
Yes, sir. I think.
Okay, see guys, N and NP students, I know you guys have gone through the static and dynamic NAT concept. Okay,
Yes,
have you guys gone through the PAT concept? PAT, static PAT, dynamic PAT, N and NP students? No?
Yes, sir.
Okay. All right, guys. See, in the real time, let's talk about the real time, how the NAT works. In the real time, there are 2 categories of NAT. One is source NAT and another is destination NAT. There are 2 categories. One is source NAT and destination NAT. Okay. Under the source NAT and destination NAT, we have the concept of what? NAT, and we have the concept of PAT. NAT also we can implement. These 2 are nothing but implementation method. Under NAT, we can implement the NAT with static and also we can implement with dynamic. Correct? Under PAT also we can implement PAT as static and dynamic. So basically these are nothing but implementation method. But 2 categories of NAT are source NAT and destination NAT. Okay. So NAT you can implement in a way of static and dynamic. PAT also you can implement as static and dynamic. See, let me tell you one thing. In case of Cisco, you can take any firewall, ASA or FTD firewall. Okay. Because mainly all these NAT configurations, either it will be done on a router or a firewall. In case of a firewall, it is also a router. Okay. That means in case of Cisco, you have only 2 implementation method. In Cisco tells you there is no concept such as source NAT and destination NAT. In case of Cisco, it is all about static NAT, dynamic NAT, static PAT, dynamic PAT. In case of Cisco, it's all about static NAT, dynamic NAT, static PAT, dynamic PAT. The way you implement it will define you what kind of NAT you are using, whether it's source NAT or destination NAT. Okay. That means if you take any other vendors like Palo Alto, FortiGate, Sophos, Barracuda, whichever other firewalls or other vendors, if you take over there, you can implement the NAT with the help of source NAT or destination NAT. They have a separate tab to configure destination NAT or source NAT. They don't have the concept of static or dynamic NAT or static or dynamic PAT. They have the concept of source NAT and destination NAT. That means when you're working in a corporate, they will tell you either I want to configure a destination NAT. They will not tell you I want to configure this kind of NAT or PAT. They will tell you I want to configure destination NAT or I want to configure port forwarding. Got it? Now you understood the difference. In case of Cisco, this is not there. But in case of any other vendors, this is the concept. In case of Cisco, only 2 implementation method, whether it is static or dynamic. Only 2 implementation method. Now let us understand how this implementation method will define what kind of NAT we are using. Right? Yes, guys. See, source NAT and destination NAT are there in case of this method. But you should be able to differentiate whether static NAT is source NAT or dynamic NAT is source NAT or static PAT is source NAT or dynamic PAT is source NAT or all these are destination NAT. You should be able to differentiate it, right? So how can we differentiate it? What is the concept of static NAT? What is the concept of source NAT? Both the things we'll be seeing here. Okay. And in an interview, they will directly ask you a question about destination NAT. A direct question will be there, explain destination NAT. Because this is everywhere this is implemented. Even now, we are also planning, not planning, we are already implemented with it. We are going with the configuration of destination NAT, and then we will give the RDP session for all the remote access. All the remote access will not be with the Ultra Viewer or AnyDesk or anything. We will not use any of the remote applications. We will use destination NAT. Then nothing but port forwarding. This is nothing but port forwarding. This is nothing but port forwarding. Clear? Now, first, let us go with static NAT. Let us go with NAT. Under NAT, let us go with static. Implementation method is static. Let us consider, guys, consider this as a firewall or a router. It doesn't matter. Okay. You can consider this as a firewall, ASA firewall, FTD firewall, or a normal Cisco IS router. Got it? Because N and NP were not aware of firewall, right? That means also no need to worry. Consider this as a router. That's what I'm telling. Clear? All right. So now this is our inside. That means our LAN. Here we have a switch. Consider to this switch, we have multiple PCs connected. Multiple PCs connected. All right. And on the outside or on the WAN side, it is connected to what? Connected to ISP. And on the ISP side, this is public. That means you have multiple servers. Like for example, if you want to access, you have to access the YouTube with the public IP address, right? Let's see. Consider this is your youtube.com. youtube.com. All these are publicly available servers on the AC, no? AC. And then here consider we have one more server, Twitter server, twitter.com. Okay. So here, let's take the gateway outside as on the WAN side 11.1.1.10, and on the LAN side it is 10.1.1.10. And here the IP address is 10.1.1.1, and here the IP address is 10.1.1.2. Here on the YouTube side, the public IP address, let's take as 20.1.1.1, and here it is 30.1.1.1. Clear? I hope this is clear. This is our ISP. This is our ISP. Now consider there is no NAT or anything. Let's consider without NAT what will happen. First, always, whenever you are going with any of the concept, first you have to understand why. You have to put a question on why this is there, how this is happening, and what is this. Okay. So now, why do we need NAT? Now let us take an example as without NAT, what will happen? I want to access this YouTube server. Consider here the port number 80 is enabled. Here also port number 80 is enabled. Okay. And here SSH is also enabled. Here HTTP yes is enabled. Okay. Now from PC1, this is PC1, this is PC2. Now from PC1, I want to access YouTube server with SSH. Okay. We have a source IP. Let us generate a packet. We have a destination IP. We have source port. We have destination port. What will be the source IP, guys? Online. What will be the source IP address?
10.1.1.
10.1. What will be the destination IP?
20.1.
20.1. What will be the source port?
Random.
Random means dynamic.
Dynamic.
What will be the destination port?
80.
80.
I want to access SSH.
22. 22.
22. 22. Okay. So this is my packet, right? This is my packet. My packet is going to your firewall or your gateway or your router, whatever you want, you can consider. This is your gateway. Let's take this as gateway. This is gateway. It can be ASA firewall. It can be normal iOS router. It can be even FTD firewall also. Here the concept remains same, guys. It doesn't matter what you are using. Packet will go to the gateway. Why it will go to the gateway, guys? Why this packet will go to the gateway?
To go to the other network.
Exit point.
Different network, right? You are going to 20 network. If you want to go to any other network, first you have to go to the gateway. Now, what will your router check? Will it check the source IP or destination IP or source port or destination port?
Destination IP.
Yeah, based on the destination IP, your router will forward the packet. It will come to the ISP. What will your ISP check?
Source.
Destination.
See, your ISP is also consists of thousands of very high-end routers, guys. They are interconnected with each other, you can say. Without having the connectivity, how do you think like your packets travel from India to US? There is something called as connectivity, right? There are thousands of routers interconnected with each other, you can say. Got it? So now this packet will go to the ISP. What will your ISP check? Destination IP. Based on the destination IP, it will forward the packet to the YouTube. YouTube has received a request. Now let us generate a reply. This is the request packet. Let me generate a reply. Source IP, destination IP, source port, destination port. What will be the source IP now?
20.1,
20.1 destination IP,
10.1,
10.1.
10.1 source port,
22.
22 destination port,
random.
whatever the random port number it has, that one. Correct? Now, this packet will come and will reach the ISP. What will your ISP check? Destination IP.
Destination,
Now, will the ISP forward this packet?
to gateway.
No.
Sir, an
not
ISP
provide.
private IPs are not routable.
Yes. According to this packet, what is your destination IP, guys? Your ISP also consists of router, right? Router will check what? Router will check the destination IP address and forward the packet. Now, according to this IP address, your ISP routers has the capability only to understand the public IP address. So, what is the main difference between a private IP and public IP? What is the main difference?
Private IP not routable.
Not routable.
Yeah, private IPs are not routable over the ISP. Only public IPs are routable over the ISP. Now, if you look at this reply packet, according to this reply packet, what is your destination IP, private or public? Private IP
Private.
address. So, your ISP will not be able to recognize this IP. It will drop the packet here only.
Yes, sir.
Got it? So,
Yes.
this is one of the main disadvantage without having a NAT if you are going to the internet. Will not get any response. That means you need the translation also. You need the translation to a public IP address, right? So in case of static NAT, guys, it's all about one-on-one mapping. In case of static NAT, it's all about one-on-one mapping. If you have n number of private IP address, then you need n number of public IP address. If you have n number of private IP address, then you need n number of public IPs. That means if you have two hosts in your network, right? If two hosts wants to go to the internet, you need two public IP address. N on mapping, n on n mapping. If you have n number of hosts, you need n number of public IP address. Are public IPs free? Are public IP addresses are free?
No, sir,
No,
expensive.
guys, it's costly. It's costly. Public IPs are not free. It's costly. Okay. But in case of static NAT, this is how the logic works. If you have a number of private, you need a number of public IP address. Now, how many hosts do I have here? I have two hosts. Now, I need public IP. Where do I get the public IP? I get the public IP by contacting the ISP, Internet Service Providers. I will phone them and then I'll ask for two public IP address and they'll give me two public IP address. And consider they are charging around 30,000 per month for one public IP address. That means it's not free, guys. It's costly. Okay, consider in that way. They are giving me 200.1.1.1 and 150.1.1.1. So I'm getting two public IP address, but obviously it is costly, right? But in my network, I have two hosts who wants to go to the internet. Is that clear? So now I have two public IP address. Now what I'll do is in my router or in my gateway, I will do a translation. This is called one-on-one mapping. Static NAT is called one-on-one mapping. So what I'll mention here is, I'll mention if you are coming from 10.1.1.1, I will map 10.1.1.1 with 200.1.1.1. I'll translate 10.1 to 200.1. What is the full form of NAT?
Network address translation.
Network address translation. So I will do the translation from 10.1 to 200.1 and then 10.1.1.2 to 150.1.1.1. Okay. So two NAT translation I have done. Static means what, guys? Manual. Now, if you have hundreds of PCs and if you have hundreds of public IP address, I need to do 100 configurations. One mapping will take 3 commands means if you have 100 hosts, then you need to type in 300 commands. That is also one of a hectic thing. Am I right? This is how static works, one-on-one mapping. You have to map each and every private to each and every public IP address. Clear? Now consider I have done this translation. Okay. Now your request packet will be generated from this PC1. It will reach the gateway. What will your gateway check? It will check the NAT. Now tell me guys, one thing I want to ask you all. Now consider here on this interface, I have applied ACL. I have configured NAT. This interface I have configured ACL. And also I have configured NAT. I have configured VPN. All these things I have done, I have configured. Now consider here the access list where I have applied. If you are coming from 10.1, action should be deny if you are going to the port number 22. If you are going to the port 2022, if your source is 10.1 and if your destination is for any with the port 22, then action should be deny. I have created one access list with the action deny. Now tell me, when this traffic comes, will the translation happen or not? Or will the traffic be denied? What will your gateway check? Will it check first the access list or will it check the NAT or VPN? What?
First, it will check access list.
Sure.
No, sir. First, it will check the NAT, sir. Translation.
No.
Then it will
First,
check
it
the
will be
VPN
access
and
list.
NAT, sir.
First, it will check the NAT, guys. First, it will check the NAT, not ACL. Not ACL. First, it will check what? NAT. Understood? Okay. Yeah, NAT, VPN, ACL. Understood? All right. So now what will happen? First, the translation will happen. According to this particular policy, I have done a mapping. What will happen? As soon as this packet is received on the gateway, what will your gateway do? Your gateway will translate 10.1. You are receiving the IP from 10, your request from 10.1. 10.1 will be translated to 200.1. Destination remains same. Source port remains same. Destination port remains same. Translation is done. What happened? Now, this packet is going from where? This is going from your gateway. It will go to the ISP. What will your gateway check? Source or destination, guys? It will check the destination, right? Is there any changes on the destination side? No. It will forward the packet to ISP. What will your ISP check? Destination. Based on the destination, is it private or public? Public IP. It will forward the packet to the YouTube, right? Now let us generate a reply. This was the request. Now let us generate a reply. Source IP will be 20.1. Destination will be what now? From where did you receive the request? You received the request from 200.1. That means your destination will become 200.1. Source port will be 22. Destination port will be random port number. Who didn't understand this concept? Online?
Understand, sir.
Okay. So now this is your reply packet. Reply packet will come to the ISP. What will your ISP check? Destination IP. What is your destination IP? Private or public? Public IP. That means he will forward this particular packet to the firewall or your router. Got it? Now what will your router check? Destination IP 200.1. Where is 200.1? Is anywhere configured here 200.1? No. What will your gateway do is it will untranslate the IP back. Okay. So you are receiving the request packet, right? This is not a request. This is a reply packet. So again, what will happen? Your 200.1 will be untranslated back to 10.1. So here source will be 20.1. Destination will become 10.1. See here, 10.1 translated to 200.1 during the request. When the reply is coming, 200.1 will be untranslated back to 10.1. So 10.1, destination port is 22. A source port is 22, destination is random. Now this is the untranslated packet. Now where is 10.1? 10.1 is here. It will forward the packet. Look at the request packet from which got generated from PC1. 10.1 is the source, destination is 20.1. Look at the reply packet. 20.1 is the source, destination is 10.1. You are supposed to receive a reply back to where, if your source is 10.1, your destination will become source will become destination during your reply. Simple thing. Okay. So you are expecting a reply from 20.1, right? So you have received a reply from 20.1 only. Got it? Now, understood this up till here? Understood, guys, or any doubt or any questions online?
No, sir.
What about
No,
others?
sir.
Akil, Akila, Amya, Avesh, Mahesh, Manikandan, Manjunath, Manoj,
No, sir.
Ravi,
No. No any
No,
question.
sir.
Selva, Sharan, Shivram, Simran, Samarth. Overall 20. See, initially how many students were there? Around 30 something, right? 30, 32 students were there. Now you see. See, the access will be given. Understand now also. Interview prep access. See, for you guys, no need of access also, you know. Every day you are going through, right? Oh yeah, forgot. Yesterday something I had given, right? Task. Okay. How many of you have done? Yeah. Nice. I forgot, guys, this part. Tell me. I remember. Now I remember. CWS. What is cloud? I mean, congestion window reduce. CWR. Okay. And then what is where you can use the urgent flag and push flag. Give me an example where you are using the urgent flag and push flag. All right. I forgot this part. All right. So now, Raghu, explain it. Raghu, what is congestion window reduced? Congestion window reduced. Didn't make a note of it. Simran, what is congestion window reduced?
When there's synchronization phase happening between the client and the server,
Mhm.
we'll have this CWR and ECE flags set.
See,
Sender will
I don't care whether you are seeing and telling it or without seeing you are telling it, but give an answer. I don't care whether you are browsing the Google or not.
No, I
Give
have
an
written down the points.
All right.
But I just really didn't understand it much because it has a lot to do with the congestion and all of that.
Mm-hmm. Yeah.
So I just understood the fact that when the synchronization phase at the beginning between the client and server is happening,
Mhm.
in the sync packet, it will be going with ECE and CWR flags set. And if the receiver is going to send back that in SYN plus acknowledgement segment, right, the second segment, it has to send a reply with ECE flag only set. So it says that if there's any other configuration, then it indicates that it's a non-ECN setup. But I really didn't understand this concept.
Okay, at least you have tried. All right.
Yeah.
What about Akila? Amir Ahmad, give an example on urgent and push. Give an example where you are using urgent flag. An example where urgent bit will be on. Push. Give an example where push will be used. Give me an example. That yesterday I explained the same thing. You don't give the yesterday's answer. Tell me where push. Example. You didn't get. Now only if I search and if I get it.
Multimedia strip.
Okay. What about Manoj? Difference between urgent and push. Yeah, you tell me the answer. You tell me.
Sir,
The
urgent is will be processed in the buffer for will be
yesterday I
prioritized in
explained
the
the
buffer.
same thing, buddy. I don't want that one. I gave. What is my question? Give an example where we use an push and urgent flag. Right. That is what my question was.
Sir, in
Right.
urgent, when consider there are sender and receiver, sender has sent one window segments to the receiver, but receiver didn't send the acknowledgement back to the sender. So
Okay.
in that time, the sender will be keep waiting for the acknowledgement. After some time, the connection has to be closed. So sender set reset flag and push flag. Sorry, urgent flag. Then sends to the receiver. The receiver will be processing the window remaining segments. In that buffer, this reset will be prioritized first. This is where urgent bit is used.
I asked urgent and push. You are explaining for reset. What about Rakshit Kumar? Explain congestion window reduced. One flag you can't learn. I'm telling you, I don't care whether you are reading it out also. Hajratiya, what is, give an example where push is present, where push bit will be on.
Sir, in push, telnet and SSH during that connection, push bit will be used.
During
And also HTTP request get message.
Okay. Okay. Simran. What about Rakshit Kumar? You're not there. Okay. Rohan, explain urgent. I don't want chat box. Explain urgent. No? Don't explain me what I have explained yesterday. Give an example. I didn't okay, you didn't attend yesterday's class, Rakshit. Okay. What about Sharan, Raghu? I gave only these three things, right? Till now, have I given anything else to do? Nothing, right? This is so that you will be learning. I gave these tasks so that you will at least do some research and see. Tell me honest, here I see like only 2 or 3 people have been, not 3 also, only 2 people. Yes, Imran. I told you, I don't care about how you are giving, right? I told you, even if you read it out also, totally fine. You're not doing that also. Amir, Akil, Akila, Mia, Aves. All right, guys, see you tomorrow. Make sure that you are preparing these 3 things and then coming. Okay, we'll catch up tomorrow at the same time. Bye.